Hi there. In this video, we will be discussing one of the other very useful machine learning model, that is logistic regression. And it is used for classification problems. Now, in the name, there is logistic and regression, but it is used for classification problems. Let's discuss how. In the classification problem, a quick review. In a classification problem, we know the number of labels, right? We know whether it is a patient of diabetes or it is not. There is no any other label. Whether the labels can be 40 or 50, even more than 10 or 20, but we know the number we know the number of labels that we are going to predict. So how logistic regression will work, it will not directly tell us what it is. It will not directly tell us whether it is a patient of diabetes or he is not. He will give me the probability for each of the possible value. What I am trying to say, let's say here is the probability that he is a patient and here is the probability that he is not a patient. So what my model will do, he is a patient, he is not a patient. Remember, the probability is out of 1. So he is a patient, our model can say a 0.7. And he is not a patient, our model will say 0.3. Now, this is not the real scenario, but this is how the model works. But for now, it is just for example. We haven't trained any model which is predicting this yet. And after that, we will see which probability is more, 0.3 or 0.7. Here we see 0.7 is more, and what was this? This was that he is a patient of diabetes. Now I will say, okay, my model is predicting that he is a patient of diabetes because the probability for that label was more, right? Now we have another example which will clear the concept even more good. And this example, we already have done the iris dataset, right? So what was the labels we were having in the iris dataset? It was setosa, whether we are having setosa, or it was virginica. It is setosa or virginica or versicolor, right? Here I'm writing VC and it is versicolor. So these are the three possible predictions that our model can make. So what logistic regression will do, it will, like k nearest neighbor, it will not work like that. K nearest neighbor will find the nearest neighbor and predict the same. But in this case, we will have probability for each of the class. What I mean here is, for every prediction, for every new feature, our model will say, okay, it is a setosa. There are 0.3% chances that it is a setosa. For Virginica, it may say there are 0.5. Okay. And for versicolor, it will say, okay, there are 0.2 chances that it is a versicolor, 0.2. So within that, we see that the Virginica probability is more, right? So we will say, okay, this is a Virginica. So this is how the model will work. And one thing to always remember, all the probabilities, you take all the probabilities and their sum will always be equal to 1. So that's the like rule here. Or when you add all the probabilities, it will give you 1 and it will remain same whether you have 40 features or 45 features or 2 features or anything like that. In the previous example, I was saying 0.7 and 0.3 and we add them, we get 1. In this example, add these three values, we will again have 1. So that's how the linear logistic regression will work. It will give prediction, it will give probability for each of the label, and then we will classify the maximum probability as our predicted value. And this will not work for the regression problem for sure, because in regression problem, we don't know the number of output. So how our model will give the predictions when we don't even know how many outputs can we have? Because here in this example, there were only three possible outputs, right? So this is how the logistic regression works.